the South American branches, officers. Welcome, Nico. Hi, how difficult it is to give a presentation after the fiddle, after the violin. I'm going to try and do my best in order not to bore you. Before I begin, I'd like to see and ask how people are doing and to know things about their experience, especially in relation to what I'm going to be presenting here. I'd like to know whether anybody of you ever used one of these remote systems or tools. But if before we begin and deal with technology, and if you're sitting here, I imagine it's because you're a computer expert or you're interested in this. And if you're somehow interested in computers, I imagine you'll be the computer guy in the house. So there's always a relative, somebody who goes and says, my computer is not working. So you go, why? What's wrong? And they'll say, it doesn't work. I don't know, it just doesn't work. And all of a sudden there's silence happens between family members, and there's always an answer. So what do we all answer? 99% of family problems related to computers are solved by restarting the computer. So what happens when we take this to the world of true, real hardware and cloud and servers? And it's no longer the computer, my grandfather's computer, etc., but it's a huge data center that has a huge amount of servers with similar problems than our relatives have. And this is the blue screen of death. And so what we need to do in these cases, those of us who work in these areas, is to go to the data center. And going to the data center means jumping on a cab. And this is like in the airports, they're always far, so you have to jump on a taxi, go to that place, and go to a computer. And most of the times, what you normally have to do is to restart the computer. But data centers, things are horrible, because note that in these pictures, people are just there, freezing cold, and this is normally a human response to when somebody feels miserable, feels horrible. When somebody has spent a lot of time in a data center, people laugh instead of crying. And this is the problem. Data centers have no place to sit down. Look at the pictures. This is just so nowhere to sit. It's cold, colder than it's real cold. And so what companies developed was the following. It's a remote system, something that can be, so that these servers can be remotely handled. The ability to restart the computer remotely. And we administrators, managers are lazy. Nobody wants to jump on a taxi in order to restart a server. So these are systems that different hardware vendors created. This is what we're going to address today. Okay, from the point of view of cyber security. Well, who am I? My name is Nico Waisman. If you want to get in touch with me, that's my address over there. So they've always tried to standardize these systems, but whenever they try, they screw up. The names of these systems change depending on who you ask. Some people call them IPMI. Intelligence Platform Management Interface. Whenever it says intelligence, it means there's no intelligence, or whatever they call intelligent, it simply isn't. And right now, and we always call some of these things lights out. Well, anyway, several names. But in this case, we're going to call this IPMI. But in any case, this is somehow complex. So what are the characteristics of these systems that are present in most large servers? And even in some PCs, there is something that's similar to this. This is absolutely independent from the operating system. Why? Well, if we have this blue screen affair, we need to restart the computer. So a micro that's handled automatically, and then this is also handled remotely. This is something we need to do from our office, and obviously there's a whole issue of monitoring, not just to shut down and turn on the system, but also to check the temperature, voltage, fans, etc. And here you can see a picture of the graphic interface. It seems that it was done in the 80s, when there was no graphic interface. And we have a chart, a table that says tells you the temperature in the different places of the CPU, etc. And it tells you about the maximum temperature that can be reached before the whole thing goes on fire. And so, for instance, after a given temperature, please let me know because something's wrong. But what we realize is that basically inside a computer we have an additional computer, a small one, inside of it. And this additional computer has several characteristics. First of all, there's a full network start, IPv6 and different protocols, HTTP. In some cases there are some lightness that will give us more capabilities, and then KVM, which allows us to share keyboard, the mouse, and a machine, and then a serial console. It's as if you were connecting a wire to the machine remotely, and this is interesting because if we want to change something in Windows, we could do it like this. And finally, power management, to be able to turn off and on and turn the computer on and off. So you may tell me, well, this is a backdoor, you may say, because it allows us to control the keyboard, the mouse, and there's no way for any antivirus system to detect things. But perfect backdoor doesn't exist because if the computer is turned off, it doesn't work. So the perfect backdoor works when the computer is off. Why? Because the only thing it needs is to be plugged in. If it is, the system is working, and here we're going to access the video, and you can turn on the machine remotely. But this is not just to run things. Obviously, if you need to reset the computer, a system needs to be connected, especially if we need to access the BIOS, and then you do some modification, etc. But the idea is that I can reinstall the operating system from these devices. And I say, no, there's a Chinese internet device that's working very well. Well, no, this is included in each server you will find. They all have this. But when I started studying this, and later on I'll tell you why we started, when you find these charts, you realize that they're big. When we see all these charts that look ugly as if they had been done in the 90s, you realize that this is trouble. The first thing we see here is the central part, this square that says baseboard management controller, the MBC. Some people think that this is a synonym of IPMI, and this is the micro. Each vendor has a different micro, and it is connected to the different areas in the computer. It uses a protocol called IPMB, and it connects to the CPU and the electricity, the mother, and it's got a direct connection to network port. It doesn't use a normal network. It uses a separate network, separate from the normal one. So we'll leave this for the end. Who has this? They all have them. There's no vendor that doesn't have this. In HP is ILO because it's intelligent lights out. And in the case of Lenovo bought IBM, and this is called IMM, intelligence management something. And then the super micro. And but let me tell you about how fun it is to go into these devices. Well, it's not very pleasant. This is and it's not fun at all, and let me tell you why. If this works, so if we can get some sound. Like I told you, this has the ability to work even if it's not plugged in. We need to switch on the device. In our office we've had Dell, HP, Lenovo, and they all make that horrible noise because of all the fans instead of inside the case, inside the box. So what were we looking for when we started studying this? Well, we needed to look for something that was pre-authentication. So what I'm going to tell you about has to do with working without a pre-authentication. How can we do this without knowing anything about users, passwords, etc.? And you realize that it's not so difficult. Right now, it's not difficult at all. It's not difficult at all. First of all, let me tell you about each system. This is something we're still doing, and we've found we've worked with several clients, and some clients told us we have these devices, but we don't trust them, and we need you to give us a hand and look into it. And the first thing we investigated, and this is where we did the most important thing, was the HPILO with a micro called NEC V850. It's not a super micro. It's slow. You need to be patient, and it's a runtime operating system that's called Thread X. When you try to unpack this, it's there's no file system. It's a great binary that you need to study, audit, and it's not easy. And this NEC V850 assembler is very easy to read. You don't have thousands of instructions that you need to follow, and this makes things easier when you go into that assembler for the first time. Assembler is a machine that's not normally used in Spain's Spanish, but in any case, so we say let's go to 4. Now everything we know about ILO 2, we're going to transfer it to ILO 4. But we cannot do it because the operating system's changed. Now we have a different thing called GHS integrity. And there are many complications, but in any case, there's compiler. These are things that are used very much, very easy to emulate. And then we have the other thing, the IMM of Lenovo and the Dell one, the IDHAC from Dell. Has anybody heard about Super H? This is used for some things, and also for Sega Saturn. I don't know if you remember this game console. This is a very powerful micro. This is not a very powerful one, by the way. But the good thing is that it runs on Linux. There's a whole file system, the configuration, and it's got different tools. And the true thing is that it's very comfortable to study, to audit. And the macro that I mentioned at the beginning that also runs on Linux, so it makes it quite easy to study.
Auditar binario por binario que ponerse a auditar un archivo gigante. Porque un archivo gigante uno quiere saber.
This is much easier to audit. It's not like with a huge file. Here, when you have a Linux, you just set up your file system, your own file system, and you can go binary per binary in order to handle different things. So here we need to know about the different macros, etc., and see what we need to do. But the main thing when we are auditing, we need to be, the machine needs to start to get going, it needs to start working. It works alone, even if it doesn't do anything, even if whatever it's doing is stupid. So when you're trying to understand things, the machine is working.
Cuentan cosas hermosas. Cada guideline de hay que asegurar este sistema de esta forma.
Well, here we have things that we can use to attack, and there's also the protocol documentation. You read all the documentation, and as we understand it, this served as a feedback for everything you've seen. It feeds our Pfizer. It also allows us to see things outside the normal protocol, because something vendors like, and that is bypassing protocol. They like standardizing things, and then they just skip standardization. Well, because some people do this in order to attract customers. They'll say, well, these things only work with me, so if you want to have them, you must come with me and buy from me. So everything we've learned so far, documentation, etc., is used to analyze. We do it, and then we feed it back as we learn. This is feedback that is used in order to keep going deeper and find vulnerabilities. Let's look at the attack surface of these systems. Well, these surfaces change with systems, but let's look at the commonalities. among them, and these are some of them. So let's look at some of these, and let's look at some of their problems and vulnerabilities. Of course, the first thing was a smash. A smash is a command line that helps to standardize all this. That's called DTMF. It's got nothing to do with telephones tones. It's like an ISO, like an ISO thing. What it does is to standardize these remote services. It runs on SSH, and for instance, if you connect to one brand and somebody to another, the ideas are more or less the same. So you can set up your own script, your own SSH script, and to connect yourself and get information. And that is the basics. These are the basics of Smash. But obviously it doesn't work this easy. It's not that easy. A series of, they have their own commands. They cannot support the standard ones. So in the end, you have to learn a whole new language or your own language for this. As regards pre-authentication, we need to attack the SSH that's been analyzed in depth. We said an interesting thing with this is that once we access through SSH, we can obtain a remote console. And we see what you see on this screen. This is the machine's BIOS. Like with everything else, there are some default user password. You may find many devices that are doing this. If you're doing a bench test, you have to use a default password. How do you get this? It comes with the documentation. And then there's the SNMP protocol, which is a protocol. And there's the community string. Obviously, like with all internet devices, most of them have public as default, or community string by default. And this is a test we ran with the walk, which is a tool that tries to list all the information provided to us by SNMP. And these are the different protocols that help us monitor the system remotely. And the interesting thing about this is that SNMP walk has information, and we extract the MIB from each these.
Nos permite obtener a veces procesos que están corriendo.
Now this allows us to access these processes that are running, and it's very helpful as attackers to know what is running, what isn't. The SNMP, well, most of these are vulnerable. The ones that you see on the market are vulnerable to a dangle pointer. The bug has been reported, but that's about it. So we need to, most systems with open SNMP, this is open for free for, and then there's HTTPS, and this is very interesting. This is one of the most interesting targets preferred by sysadmin and firewalls. You can connect to this system. We've had several companies with these devices. Something that was open was HTTPS. The device doesn't let you go in through HTTP. It redirects you. Some devices are so old. and the certificates are so old that we had to go back to a 1.0 Firefox version in order to access the graphics interface.
Most of them use a web server called APP Web. It is interesting. It's very small, supposedly safe, and this web server is indeed safe and secure, but the problem is the things that it has on top, and that we will see in a minute. People say, I'm not going to use APP Web or Light Web or any other things, and some people decide to implement their own server. You may smile because you may think that this is the end of the problem, and indeed it is. For example, in the thread number 4 of these guys from France, they reported HTTP server in a way that was the one we were looking for. There was this virus called SSCanF. It's a Stack Overflow, very easy to trigger. It was the perfect unit, and they won very clearly. Supermicro is another pre-authentication exploit example. One wouldn't be able to attack the web server as such, but if you log in, CSIs, which are created on C, are sometimes compiled without any security whatsoever, without cookie protection and many other features they don't have. This Stack Overflow, this is a bug from the 90s and appeared about a year ago. And what you can see here is that they get the name and the password to log in, and then this is string code. They copy a variable, and then it can crash and it can be exploited in a very simple way. When it comes to recognizing these systems, HTTPS allows you to enables recognitions without authentication with these 2 URLs. The first one gives you information about the firmware it's being used, because otherwise you cannot target it specifically. In the case of the iDRAC, they have a CGI called Discover that may be hacked in the future, but we haven't found anything yet. It's not only about web server, it's what is on top of the web server. In this case, we've seen 3 specific protocols that are used in different web servers. The first one is Waisman, the second is Redfish, and well, I will go one by one. Redfish is the newest one. It is a communications technique, very simple one. The endpoint is redfish/1/, and what's interesting about it is that it is very well armored. The authentication is done at the level of the HTTPS server. So if you authenticate yourself this way, there's little you can do unless you attack the server itself. On the pre-authentication level, there's nothing else you can do. So we looked at it, understood it a little bit, but we didn't delve into it because our time was limited, and we had to somehow work on the economy of what we were doing, like how we would invest our time. And if things got too complicated, we just moved on to the next thing. So we moved on to RIPCL. This is a protocol, an XML protocol, where the authentication is in the XML itself. Now we know that the authentication doesn't go through HTTPS, and that's an advantage. Web server is solid, so let's try to attack XML. So we started fuzzing, first of all. But before going to that, What's interesting is that administrators don't write XML by hand. They use these tools, HPO, NCFG, and CPQL-OCFG, one in remote, one local. They use a series of commands and they create an automatic XML to remotely administer the machine. What's interesting about these kind of tools is that the administrator isn't writing emails by hand. And the advantage to this is that many of the units that are found here are done by administrators by accident, and when they send it over, they crash. When they use an automatic command, it's usually standardized stuff that leaves us room in order to test weird things, in order to find vulnerabilities. So this is an example of how it works. Authentication, it's in the XML itself, beyond the first header that tells you about the version. Then we have entries for user, password. If it's in plain text, it's not important. And then if this variable happens, it says host powers, and it powers off the device. The problem is that when we started fuzzing it and analyzing it, we found out they were using a solid lexic analyzer, Flex, Escango, and a lot of very well verified things. So what we decided to use was Radamsa. Radamsa is a great fuzzer that allows you to work immediately with it in very simple steps, in 4 very simple steps. We use it for everything. Before starting analyzing or auditing, we use Radamsa right away. It's very simple. We decide what to attack, first of all. Second step is to look for valid cases. In our case, looking for XML. We were looking on the internet, things that acted on the machine, for example, that turned off the machine. The next step was to make a balance. If these are the valid cases, we used Radamsa to turn those into bad cases. And they have lots of buzzers. They have many different algorithms in order to change whatever we were sending to it. We were sending XML, but we've used binary protocols, things that weren't XML-based, and Radamsa got it, read it, and without having an idea of what it was about, it was given us things like these back. They were doing, it was doing crazy things, for example, closing the login several times. Here you can see that the version appears several times, and this is without knowing XML, because probably the algorithms it has inside can understand that the brackets are able to limit things in a certain way. So this is the first logical step in any audit. This is the next one, Waisman, which has nothing to do with my name, by the way. It's Web Service Manager. It's a protocol that is widespread in Microsoft. I don't know how they used it, but they use it as a native support, and they have a similar syntax to XML based on the SOAP. And since Microsoft uses it, it has a lot of PowerShell support. So Windows users use it a lot, actually. But there are several problems attached to it. First of all, because it's not linked to a transport layer. However, it's usually used through HTTPS with /Waisman. But on the authentication level, this is managed at the web server level. That's why we thought this wasn't the best option. But we found out that it could run standalone as well with the TCP/5985. So, in spite of using HTTPS, in some cases it wasn't working as it was supposed to. For strange reasons, they wouldn't let me administer it remotely without authentication, but it would let me speak a little bit. And as long as I can speak, this means that it is patching. And we know that it's for vulnerability purposes. Parsing is the worst, not patching. Parsing is the worst thing you can do. So we said this is good. This is a parser. It's letting us speak. So let's see what else we've got. Supermicro is using a very, very old version with a lot of vulnerabilities. As you can see here in the middle, beyond the string compares, you have a sprint F. I cannot use my laser pointer. It's not working on the screen, but anyway, it's what you are watching on the screen, sprint F. This is a similar one. We're talking about sprint F bugs, and now modern stuff can detect this kind of behavior, but I don't know how they compiled it, because it let it be as it was and unleash an overflow. Some others use newer versions, and what is interesting about them? Well, this is the version that is running as standalone. What you're watching here, this is an open source version that was adopted for every single system. So as we said before, when we are implementing our own web servers, there is risk of vulnerabilities. So since we knew that there were vulnerabilities such as sprintf, we decided to find out more. Here there is another vulnerability when the web server tries to authenticate via digest or basic realm. There is a problem. So that printf is okay, or it looks like it is okay, but as long as you advance and as the loop turns around, this n value increases. So when I do size of minus n, I am going to be allowed to write as much as I want. This is a pre-authentication vulnerability as long as the system is running standalone. That's what most of those kind of systems adopted. So as we discover more and more about this, we actually couldn't believe it. IPMI has its own protocol with the same name, IPMI, which runs in UDP and 623. And it's quite interesting. I encourage you to test it. It learns, or it enables you to do what the interface provides, but only on UDP. So we can turn on or off the computer, find out information, etc. So we started to look for more information, and ID World called it the most dangerous protocol in the world. But you know what magazines and journals are like. If they say it's the most dangerous protocol, we just don't believe them, because they are always talking about very dangerous things, and sometimes, and many times, they are wrong. So we started looking at how it worked, basically only with UDP, and they use a session ID and a sequence number in order to start the session. And now we can see how it works. There is a first package, first basic package, that tells you what is and what isn't supported, and it's called Get Channel Authentication Capabilities, that responds immediately. This is all pre-authentication, not post-authentication. This is how the protocol works. The first layer is called RSCP, and it's the remote management layer. It works also internally, by the way, locally via a pipe within a machine, or it can even work with the bosses even. So in this case, this layer tells you that the program is running remotely. Then we move on to the session layer. Beyond UDP, when you want to know who you're talking to and avoid spoofing, you need the first value, the sequence value and the ID. We have a length that is going to give us the identification for the next layer of protocol. We're going to know how long it's going to be. A binary protocol needs to test whenever they see there is a length. Then we have the IPMI layer itself. This is what we call the 38 command. We send that command, and what we get back is the same. We also attach the privileges we want to have in the future when we are authenticated. So we send this over and we say, well, this is the kind of thing I support. Tell me what are your authentication channels, and tell me also what are the algorithms you support. These algorithms have to find out the IPMI version that is running. The oldest one, I think, is 1.5. And then there have been other newer versions. They all support 2.0, but we need to find out what things of 1.5 are being supported. And here we find out if no authentication is accepted, if MD2 or MD5 are accepted, and so on and so forth. If they accept a non-authentication, this means that I can use this tool to connect myself in Windows and Linux, and I can type in many different ID names and passwords, and it would make no difference. I will be able to authenticate myself without any username or passwords. The tool accepts these arguments by default. This was the beginning of the protocol. Here we're talking about the 2.0 version. And if you start researching, there are no machines that can accept that remotely, although they can tell you they do. So what was the answer from one of the vendors? Dell, for example, said that the equipment wasn't conceived to be on the internet. It was conceived to be on an isolated network. That's why we let you authenticate yourself without a username or a password. Now let's move to the new protocol, the version 2.0. How does authentication work here? Now it's your turn to find out what the problem is. This is a vulnerability that you can find if you follow these specifications. The first packet is open session request. I tell them I want to start a session. I know I'm running out of time. That's why I'm speaking extraordinarily fast. So we have the local session ID. Remember, we used sessions in order to find out who the person was. So I sent the request, and the other party tells me that this is my remote session ID. This is how we communicate. Then we launch the first package. We authenticate ourselves seriously. This is the username I want to access. So the root, the admin, whatever we want. And then I send a value, a random value that is going to be used in order to encode that value and find out if it's been used or not. So the yellow is the client, it's me, and the other one is the server. So it tells me this is my Git, this is my server name, because every server has a unique name. I get a random value as I sent mine, and then I get my hashed password. Then we move to the second stage. Now I have all this information that allows me to hash a code and send it to the server that says, okay, it's you, you can continue. Have you found what I asked you to look for? Exactly. The server is sending us the hash of the password. So we just sent a login name, and the server sends us the hashed password of my own name. And why? This makes no sense at all. Not even in the protocol you can say, okay, this is okay, it was patched. No, it's not patched. The protocol is like that. So in this case, well, you know that we've salted it. How have we sorted it? Well, with all the information I got from the local session ID, remote session ID, local random bytes, etc. It's used with the password in order to hash this value and give it back to me. We're talking about a hashed password here. So what I do in this case is crack it. I have all the time in the world for cracking it, days, weeks. As long as the password doesn't change, everything will be fine. So this is the Python dump I made in order to test with different users. And with every user I try, I get the same. What you see in blue is the salt. And what you see at the bottom is the hash. The hash I got using the admin user. If you see the difference, one is admin in capital letters and the other one isn't. So here, John and Hashcat have a support for this. And the cost of this is $24.48 per hour, which gives us many million attempts per second. Well, you've talked about hashed passwords, so this looks pretty easy to do. But people at Dell made yet another mistake. I remember I said they used a session ID and a sequence dumber. They decided that the session ID would analyze the last 4 characters in the 32 bits. As a result, if the connection is active, you might be able to predict the session and hash it and hack it. On the other hand, there is a protocol that we haven't seen yet, but sounds very interesting, and it is the KVM. It's very interesting, and it allows you to remotely control mouses, keyboards, etc. As long as you go into the website and as long as you use Java applet. It is a unique protocol. We don't have time to see it, but the authentication is almost immediate. We decided to analyze this in more depth in the future in order to find out if it was really worth it. I'm not really interested in what is online. I will tell you why in a minute. And the things we were able to see in several websites and databases that are out there on the internet is that most of them still accept MD5 for the 1.5 version. What is surprising about this is that the 1.5 version isn't vulnerable to this. But when they went to the version 2.0, when they designed it, nobody said or nobody mentioned the hashed passwords. So it seems nobody in this team was actually involved in security. So this gives you an idea of the things we can find on the internet. There are very few devices running on 1.5 protocols, or at least I didn't see any. There are very old devices. Then Simple Pass, which isn't very interesting to us either. Well, then I researched Shodan, and in Shodan there were 30,000 servers online with HCP, and most of them were vulnerable to bugs. I gave you the example that the French found, and it is in the last version of this thread, and none of them was running on the last version. Here we are using the 1.3 version. Then I looked for HYDRAC on the census database, and the figure it gave me was 31,000. Then I looked on the IPMI protocol. It gave me the value of 128,000. I honestly don't believe that number is real. And what I looked for with ILO and HYDRAC, they are really connected. This is what I found about Spain. Only 750 were under ILO. If you look at Shodan in Spain, the number is quite important, and they are exposed to the internet directly. Well, now again, I'm not interested if they are exposed to the internet or not, but if I am an attacker, these devices will allow me to do all the things. That is the so-called cross movement. Sometimes many times we talk about the side movement. I compromise a machine and then I can move to different other machines next to it. But this takes one step beyond. This allows me to use a different network and move elsewhere. This is a nice ICP from Holland. So this is how you get online and how you manage that remotely. So this is the way it is seen in a normal network. We have the administrator who is managing an out-of-band network, and this network connects to the different servers. These servers may be on a DMZ. They may be connected to an internal network, or they may be directly connected to the internet. What's interesting here is that they are in different networks, or they may be in different networks. This opens the doors to an attack and to a movement that goes beyond the side movement, because we can either compromise the administrator, who will open all doors, or to compromise the ILO and then see what we can do. Then we can compromise one of the servers and then move on to the ILO. So the question is, once the ILO is hacked, do we have access to the server? Yes, in many different ways. First of all, we have a serial console. We can use a serial console, and we have a login to connect ourselves directly. Then there is this beautiful protocol that allows us to set up a URL remotely. It actually sets it up on Windows or Linux. And of course, we also have KVM, which is a VNC that goes straight to the machine. I don't know if I have time to say everything I want to say. I'm going to forward this clip a little bit. What we did was to connect to the web. We raised the Java applet, and this screen that you are seeing is KVM. It's displaying everything. I tried with SSH as well. You can do it, but you cannot play the video in the frame buffer mode. So it is all blind, so to say. In the case of the Java console, you can watch the video perfectly. So first of all, we have power switch reboot. The machine reboots, but still I continue. I remain connected to the web server, to the machine, and it all moves on very seamlessly. It takes quite a while before it reboots, so I'm going to fast forward a little bit. So the machine reboots. I have a Linux installed here.
Ventanita abajo que no me deja. Vete. Vamos a ver si lo levantamos acá, ¿qué pasa?
Let's see what happens if we fast forward it a little bit. Well, it rebooted. And then I start hitting on shift all the time, and I go into the single session mode. And we move to the advanced phase.
Entrar en modo recovery.
And I want to go into recovery mode because we might have lost power or whatever. And I go into recovery and I go, instead of fixing the computer, do something else.
Está booteando el Linux en este momento.
It's booting Linux, but in recovery mode. So it sets up an interface, recovery interface.
Esto demuestra básicamente que es una forma muy simple de pasar.
This is a very easy, once the ILO's been committed with all the thousands of problems it has, and the famous hash that, see, I can go to the central server that has all the information, because a device you can connect remotely, etc. But it only makes things difficult. And here you see the recovery mode.
Más que eso, nada, y así como puse, como hacemos nosotros el recovery.
Recovery, we check the computer, we reboot, shift, recovery. If I'd had a BIOS password, it would have stopped me, but there's still a lot to see here. Here we are. And then, same thing on the other side. This is the operating system. I go into a computer, the operating system lets me flash the firmware. This also depends on the vendor. Each one of them have their own way for communication. There's also Bootstrap, and this yeah, what allows you to do many more things. But this, I commit the machine and I see whether there's an ILO that's connected to it. Once I see that this is the case, I have my own ILO signature, and then imagine that the machine is committed to internet. So let's imagine that I'm going to connect myself to a net that's outside the rest of the networks. Something that the engineer didn't design, because he's thinking about a layer of servers, but he's not thinking of a parallel network that connects these servers, and where a normal network is connected to DMZ. I'm not interested to whether these devices are or are not connected to the internet. The idea is to be able to connect with different IPMI.
Por la red que está siendo monitorizada es la que pasa el protocolo, no el protocolo de management. Pero nada, todavía queda muchísimo para analizar de esto. Hay muchos protocolos que nos quedan.
There are many protocols that are pending. There are many things that we need to do when we can publish them. Many alternatives.
Porque hasta ahora nunca fuimos.
There are a lot of management software that uses restricted accounts that can only let you see certain information. So this is something we need to see. If we commit one of these accounts that are limited, for now, this is what we see. If one is administrator, we have to maintain these devices disconnected from everything. These are devices that are useful, but if I restart these devices, they have to be connected to me, not let them communicate among themselves, because this means that I'm going to be able to move sideways. Many of these devices use very old software, and nobody's paid enough attention. Are there any questions? We have 1 minute 23 seconds. Any question?
Bueno, entonces, si es así, les agradezco a todos. Cualquier cosa, pueden
Thank
conectarse
you.
con Twitter
Anything,
o mail,
please
si
connect to
siguen.
Twitter, mail, or whatever.
Gracias de nuevo
Thank you very much for your attention.